In 2025, we're witnessing the transition from traditional search to generative AI search. With traditional search, you enter in a simple query, you view a short answer, you view a list of websites that are related to that query. But generative AI search is different. With generative AI search, these systems are responding to queries or complex prompts, maybe at the start of a conversation, maybe as part of a larger conversation. And that generative AI system is returning a whole set of content. Maybe there's links included as citations, but really the focus is on returning a complete answer to your question. And it changes how we need to think about SEO, changes how we need to adjust our SEO practices in order to show up in generative AI search. Similar to traditional search, but there are important distinctions between the two. And it's important to understand these distinctions, and the best way to understand those is by digging into the fundamental technical differences between these two systems. And by understanding those fundamental technical differences between traditional search and generative AI, we can really start to understand why generative AI search is so different from the current practice of SEO. More than that, we can really start to understand how we need to adapt our SEO strategies. So let's start with our baseline, how traditional search engines work. This graphic from Google summarizes the process. I'm not going to go through all of the details. There's obviously a lot of details to say about how traditional search engines work. Instead, I'm going to just recap the high-level points here so that we have this in mind as we start to compare it to how generative AI search works. So the first step of the process for Google is discovering a web page. After Google discovers a new URL, it places it in a crawl queue. At some point, this page is going to bubble up to the top of that crawl queue, and Googlebot's crawler can fetch the HTML code from that URL. Once fetched, Googlebot saves this information, saves that HTML code. Next, Google begins processing the fetched HTML code, and Google starts this process by separating out the different parts of the content. Here's the header, here's the title, and so on. During this process, it also resolves any errors encountered within the HTML code. Googlebot then adds this page to a render queue. So the render queue is saying, okay, wait, more work is needed to fully understand what's going on with this page. And just like the crawl queue, the page is going to sit in the render queue for a bit until it bubbles up to the top and gets passed to the rendering systems. Rendering involves processing CSS and JavaScript. So CSS code defines how the page is styled. And Google wants to process the CSS and understand the CSS to know the layout of the page, what text gets emphasized, what text gets hidden from view, what text is buried, what text is given greater focus. The other thing that they're doing at this stage is executing JavaScript code. So JavaScript code might add text, images, links, and more to the page. And assuming Google is able to render the page correctly, Google's bots will have a complete view of the page. And that's why Google is going through this. Google's work is really about trying to understand what the page is showing to actual visitors. So they spend a lot of time crawling and rendering the page to try and mimic what actual visitors to the page are seeing, human visitors are seeing to the page. After processing or rendering are complete, the rendered HTML is then passed over to Google's indexing systems, and the indexing systems begin analyzing and evaluating the page's content. This is where Google assesses what topics the page discusses. It determines whether the content meets its quality standards. It's also here where it starts to determine what type of search intent this page could satisfy. So based on this analysis and evaluation, the page is added to Google's index. Now, a lot of pages are never added to Google's index. They're rejected. And you can see some of the reasons those pages are rejected and not included in the index in Google Search Console's page indexing report. I have a whole separate video about that if you want to learn more about that page indexing report. The point here, though, is that through all of this analysis, through all this evaluation, Google is trying to create an index. And this index is a really sophisticated representation of all the information that it's gathered from the crawl. If a page is included in the index, then the page is eligible to appear in search results. When a user conducts a query on Google, Google is going to go and search its index to find which pages are most relevant to the query. Google's algorithms then are going to make decisions about what order to rank the relevant websites. This one goes first, this one goes second, and so on. Now, there's a couple important points to keep in mind with this process as we start to compare traditional search with generative AI search. First, while Google's algorithms rely on AI, these AI systems are different from generative AI systems. The AI systems Google is using here are more about helping in that analysis and evaluation process to build up the index. They're not like generative AI systems that are trying to learn something in order to create new content. That gets me to the second point to keep in mind. For some pages, Google's algorithms may choose to extract some content from the page. It might grab a paragraph or a sentence to show in a featured snippet, or it might grab an image from the page. But that's different than what generative AI is doing. Generative AI is extracting content from a page to learn something about the patterns found on that page, so that way it can then create new content. Generative AI search is about generating new content. What Google is doing with traditional search, with bringing in a featured snippet or an image from the page, it's trying to extract existing content and represent it in the search results. It's very different focus. All right, so now that we have that in mind, let's shift to talking about how generative AI search works. Generative AI search relies on three main systems: large language models, embedding models, and RAGs. Now, I'm not going to talk about each of these in detail. Here again, there's lots of details. There's lots of nuance. So I'm going to keep this high level just so we have a point of comparison with traditional search. So the first thing that a generative AI search system uses is a large language model, or LLM. I'm guessing you already know a lot about LLMs, so I won't go into too much detail here. But if you don't already know, an LLM is trained on massive amounts of textual data, and it's trying to learn patterns and structures that exist within a language. LLMs don't necessarily understand language in the human sense, but they provide a statistical model that mimics that understanding. So when generating a response to a prompt, the LLM is predicting what words are most likely to follow based on statistical patterns. The second system that is being used in generative AI search are embedding models. In an embedding model, a generative AI system is converting the words and phrases used on a page into a numerical format known as vectors. Generative AI doesn't use words directly, it uses vectors to understand something about the page content. The AI system uses vectors to capture meaning, capture relationships, and context. So this embedding model represents words, represents phrases, represents even whole documents as vectors. And all of that encodes the relationships between content, that encodes the similarities between different concepts and different ideas. So that way it creates this idea of conceptual connections between different systems. The last thing we have in generative AI search is a RAG. This stands for retrieval-augmented generation. And RAGs can supplement the LLM by retrieving information related to the user's prompt from an external knowledge base. Some generative AI systems always incorporate a RAG. Most search engines used within generative AI do always incorporate a RAG, but other generative AI systems only rely on the pre-trained knowledge in the LLM unless additional context is required. To understand these three components better, let's use this graphic from NVIDIA showing these systems and walk through how this works when entering a prompt. So to start, you input a prompt into a generative AI system. The embedding model encodes that prompt into a vector representation. A RAG retrieves documents on concepts related to this prompt from its knowledge base. Next, the results from the knowledge base are compared with the vectors. Any matches are retrieved and passed back to the LLM. The LLM combines the retrieved data that it found in the RAG, its training, which is that statistical model of language, and the original prompt to generate a response. And then at that point, the generative AI system is able to format and present the response back to the user. All right, now that we understand the differences, let's compare the two. The crucial thing to remember is that the LLM is not trying to organize the information in the training documents. Unlike a traditional search engine, an LLM is not trying to retain key facts or figures. An LLM is not a database. This means these systems have very different goals. Search engines are purposefully designed to help us find information. That's what the index is about. Generative AI might help us find information, but it's focused on generation of new content based on a language model versus the retrieval of existing content from an index of web pages. And that really changes the strategies we need to take for traditional SEO and generative AI search. Optimizing for traditional search requires showing Google that your content exists, that your content is relevant to a particular search query, that it uses the right words. Optimizing for generative AI requires establishing relevant patterns in your training materials to explain who you are, what your business does, and why your business is relevant to the prompt that somebody is entering in. Optimizing your website is still important. However, the LLM is trained on billions of records, and it's looking for patterns across all of those records. So to make a difference in how the LLM makes its predictions, we need to ensure that our company and our website are widely discussed. So that way LLMs can learn to model words about our companies appropriately during the training process. Along with optimizing our websites, that means we also have to think about PR, branding, reputation building. So let me know what questions you have or if you need help optimizing for generative AI search. You can email me at matthew@elementive.com. If you liked this video, like to see more like it from Elementive, please subscribe. Thanks for watching.